Today we're going to work on page 816, and we're going to do problems 1 through 29 odd. So we're going to be looking into matrices. Now, we've done matrices in the past, and we taught you how to use them, and you have no idea really what a matrix is or how the solutions are created. So we are going to learn that today, well, over the next couple days. Okay? In college, there is an entire class dedicated to linear systems. It's called linear algebra, and practically everything you do in linear algebra can be turned into a matrix. It's basically the study of matrices. We're just going to scratch the surface. Okay? And then in the end, when we learn everything that you need to know for the final, I'm going to remind you how to do it the super easy way. So, but I'm not sure if the final is going to contain some of these other pieces that a calculator really isn't going to help you with. So we're going to learn it the slow way, and then we're going to review how to do it the fast way. Okay? Every matrix, if you remember, is just a set of numbers. They're rectangular boxes. They can be square, but they have, every row has the same number of elements, and every column has the same number of elements. So this is a matrix, and the order, meaning its size, is 2 by 2. The order is defined row by column. So that matrix has 2 rows and 2 columns. So if I added another column, that is now a 2 by 3 matrix. You will never see a matrix that's missing something like that. You could put a variable in there, but you will always have the same number of items in a row and the same number of items in a column. The simplest of all matrices would be this. What's the order of that matrix? 1 by 1. Really interesting. So the first couple problems on your worksheet are easy. Determine the order. That's nice. We frequently turn linear systems into what we call augmented matrices. So if I had the linear system 2x plus 3y equals 6 and 4x minus 2y equals 0, in order to find a single solution, that piece of the matrix has to be square. So if it's a 2-variable system, you need 2 equations, which means that piece will be a square matrix. And then augment just means add to or supplement. And that means you create that square matrix with the answers plugged in there also. So this augmented matrix would be 2, 3, and they put a line there, 6, 4, 2, 0. And this is the augmented portion. It just means add to. Now, you did this the last couple of years when you solved with matrices. So a 2-variable system would create a 2 by 3 augmented matrix. What would a 3-variable system create? 3 by 4. So all you have to do on that next set is write what the augmented matrix would be. You don't need to solve it, and there is a way on your calculator to solve it, but we're a couple days away from that. Your question? Oh. All right. 15 through 20 says, write the system of linear equations represented by the augmented matrix. So if I had 6, 4, negative 3, 1, 0, 8, what is the system that represents? 6x plus 4y equals negative 3, and then x plus 0y equals 8. So that's pretty easy. Okay. Now we're going to move on to something called row echelon form. Okay. Row echelon, how do you spell that? E-C-H. No S. There we go. That's a lot better. Row echelon form. Row echelon form just means the top row starts with the number 1. The second row has a 1 in the second place and zeros before it. The third row has a 1 in the third place with zeros before it. And the fourth row would have a 1 in the fourth place with zeros before it. So row echelon form, no matter how big your matrix is, on the diagonal, you will always have the number 1. So this would be a 1, this would be a 1, that would be a 1, that would be a 1, and zeros in front of it. So the second row would have a single 0 in front of it. The third row would have 2. The fourth row would have 3, and so on. Right. It's important to note that row echelon form is actually not unique. If you take an augmented matrix, and I create row echelon form, and you create row echelon form, there's no guarantee that our two row echelon forms are going to be identical. Depending on how you got there, it's not like simplifying fractions. There are multiple versions, perhaps even infinite. I'm a little rusty on that. But so row echelon form just has 1s on the diagonal, and then this space is full of zeros, and then everything else over here doesn't really matter. Now, if you remember back to when we solved matrices using our calculators, what button did we use to solve them? We went matrix, then we went to math, and we found the calculation called, remember what it was? We used the button called RREF. That stands for reduced row echelon form. So there is an REF button on your calculator, and that will turn any augmented matrix, or any matrix actually, doesn't even need to be augmented, that will turn any matrix into a row echelon form matrix. But that's like changing a fraction into some other equivalent fraction. How many fractions are there equivalent to 3/4? Infinite. So row echelon form just creates kind of like an identical fraction. So if I said 10/16, we could turn that into any number of infinite answers, but reduced row echelon form, RREF, not only puts zeros in front, right here, that's what row echelon form does, but reduced row echelon form puts zeros here. And when you put zeros in both places, then you create a unique matrix, which is actually the solution to a system of equations. So row echelon form is not actually very useful. We used row echelon form when we solved matrices by hand. Well, you don't have to, but you can. And then reduced row echelon form is what we use in our calculator to guarantee a unique answer. Okay. Now we'll show you how to solve those by hand later. That's kind of tomorrow's. So for 21 up to 29, all you have to do is look at it and say, does that satisfy the row echelon form? 1's on the diagonal, 0's in front. Now negative 1's don't count. They have to be positive 1's in order to be called row echelon form. Yeah, those are just yes and no. Okay, piece of cake. Good luck.